As a leading military force worldwide, the U.S. Air Force has always been at the forefront of innovation and technology. From the historic first powered flight in 1903 to the development of modern aircraft and drones, the Air Force has consistently pushed the boundaries of aviation. Their latest invention continues this tradition of excellence. The U.S. Air Force has recently unveiled an incredibly advanced creation that surpasses all expectations. This groundbreaking technology is poised to revolutionize the military landscape. Join us as we delve into the intricacies of this sophisticated marvel developed by the U.S. Air Force. Its capabilities are so advanced that they will undoubtedly leave you astounded. Although tactical ultra-short pulsed (TUSP) lasers have a notable history dating back to the 1970s, the U.S. Air Force has successfully transformed this technology into a versatile weapon system. This new and improved laser technology has enormous potential to enhance the capabilities of various military platforms. It has already made significant waves in the defense industry. While still in the prototype phase, this advanced laser technology has undergone a series of successful tests. It is now on the verge of deployment in the near future. Let's examine how this laser functions and understand its impressive capabilities. The tactical ultra-short pulsed laser is exceptionally powerful, boasting a peak intensity that surpasses the sun's by 1,000,000 times. Despite its incredible strength, this revolutionary laser is housed in a compact and portable device, easily carried by military personnel in the field. When activated, the laser generates a rapid succession of ultra-short pulses directed towards the target. These pulses are unlike anything witnessed before. They are so swift and intense that they can effortlessly slice through steel and other materials. The tactical ultra-short pulse (TUSP) laser surpasses its role as a mere weapon, finding utility in non-lethal applications like disabling electronic devices or temporarily blinding enemy combatants. It harnesses a high-energy light beam to deliver precise and forceful strikes to the target. This beam's intensity is so immense that it can effortlessly cut through metal, shatter glass, and obliterate electronic systems within a matter of seconds. Developed by the U.S. Air Force, this powerful laser emits extremely brief bursts of light, with a pulse duration ranging from femtoseconds to picoseconds. While the technical jargon might be unfamiliar, it signifies an exceptional level of speed. To put it into perspective, a femtosecond is equivalent to 1/4 of a second. Thanks to this extraordinarily rapid pulse duration, this pioneering technology possesses a unique ability to cut, weld, and melt materials with unmatched precision. The precision achieved is unprecedented, as the laser can penetrate materials without causing any heat damage to the surrounding area. This remarkable characteristic renders it ideal for a broad spectrum of military applications, including target identification, ranging, as well as the disabling or destruction of enemy equipment. When the laser is fired, its energy rapidly gets absorbed by the targeted material, leading to instantaneous heating and expansion. However, what's even more intriguing is the subsequent spiral reaction triggered after impact, something you've likely never witnessed before. Here's how it operates. The expansion resulting from the laser's impact generates a shock wave that travels through the material, resulting in a small explosion on the surface. This shock wave then removes a small portion of material from the surface, resulting in a clean and precise cut. Thus far, during the series of tests conducted using this inaugural laser technology, such phenomena have been observed. This immensely advanced and groundbreaking laser is now expected to revolutionize various industries, extending beyond the military domain. Now, if you're wondering how this laser achieves such extraordinary power and speed, it all begins as it gains medium. At this pivotal moment, a specially designed material is released, amplifying the laser's energy to unparalleled levels. The material used in this laser system becomes excited through an electrical current, leading it to emit photons or particles of light. These photons undergo a series of reflections and refractions using mirrors and lenses, effectively shaping and focusing the laser beam into an ultra-short pulse. However, this is merely the beginning of its capabilities. The tactical ultra-short pulse laser stands out in its own league. With its remarkably short pulse duration, it can achieve extraordinarily high peak powers, measured in petawatts. To put this into perspective, it surpasses the average power output of the entire human race by a million-fold. This unparalleled laser technology from the U.S. Air Force also possesses the unique capacity to perform nonlinear optical processes. In simple terms, it can interact with matter in ways that traditional lasers cannot. For example, it can generate high-energy photons and induce plasma formation from solid materials. The possibilities offered by this technology are exceptionally thrilling, and experts predict an even more remarkable future for the tactical ultra-short pulse laser. The military applications of this new technology are boundlessly exciting. It can be utilized to neutralize enemy drones, disable enemy vehicles, or disrupt enemy communications. Operating effectively within a range of up to a mile, it proves invaluable in various scenarios. As mentioned earlier, the Air Force's laser technology can be mounted on diverse platforms, including ground vehicles, aircraft, and even ships. This dynamic capability positions the tactical ultra-short pulse laser as one of the most versatile military weapons ever developed. Its flexibility makes it an essential tool for any military operation. According to U.S. military experts, the tactical ultra-short pulse laser is an astonishing technology with the potential to revolutionize how America defends its territory and safeguards its citizens. The laser system utilizes specialized high-power fibers composed of strengthened materials, enabling the beam to attain exceptional power and precision. These fibers are constructed using specially coated materials that amplify the light as it travels through them. The result is a laser beam that can reach speeds of up to 300 million meters per second, making it incredibly difficult to evade or avoid. This capability enables the laser to deliver highly potent and precise strikes, surpassing the capabilities of traditional lasers. Furthermore, the high-power fibers can conduct a substantial amount of light energy, greatly enhancing the tactical ultra-short pulse laser's effectiveness in non-lethal applications. For instance, it can temporarily disable adversaries during battles without causing permanent harm. Another advanced feature of this laser is its adaptive optics technology. This technology allows the laser to adjust its own beam to compensate for atmospheric distortions, ensuring continued focus and accuracy over long distances. It enables the laser to adapt in real time to changing conditions, particularly useful in fields where conditions can vary significantly. Additionally, this technology allows the laser to generate ultra-short pulses with enhanced spatial and temporal control, enabling remote sensing capabilities. The new laser from the U.S. Air Force is also capable of adjusting its wavelength. The importance of this lies in the fact that different materials absorb different wavelengths of light. By tuning its wavelength, the laser can effectively target a wide range of materials. This ability to optimize its performance for different scenarios, such as matching the absorption spectrum of a particular material or minimizing energy absorption by the atmosphere, allows the tactical ultra-short pulse laser to maintain its intensity over long distances. Overall, the incorporation of high-power fibers, adaptive optics technology, and wavelength tuning empowers the Air Force's new laser system with remarkable capabilities, enhancing its precision, adaptability, and performance across various applications. The Tactical Ultra-Short Pulse Laser, TUSPL, incorporates multiple beam configurations, allowing it to target multiple threats simultaneously, making it an incredibly effective defense tool. Whether operating in single or multi-beam modes, the TUSPL maintains high levels of accuracy and precision. To further enhance its capabilities, the U.S. Air Force has integrated a beam sweep mode function into their newest laser technology. In this highly powerful mode, the laser rapidly scans an area and engages multiple threats within a short period. This proves particularly useful in situations with numerous threats, enabling the TUSPL to swiftly and efficiently neutralize them. According to some U.S. military experts, the TUSPL's various beam configurations are what make it an invaluable tool for the U.S. Air Force, setting it apart from all other laser technologies ever developed. However, like any high-energy weapon, this advanced laser generates significant heat, which can potentially damage the system and reduce its effectiveness. Consequently, this weapon system is equipped with robust and advanced cooling systems to ensure it operates at maximum efficiency. The TUSPL's cooling system combines both air and liquid cooling technologies, working together to dissipate heat from the system. While air cooling employs fans to circulate air around the laser component, liquid cooling utilizes a special coolant to transfer heat away from the laser. The Air Force's latest laser system incorporates a remarkable feature that allows it to adjust its cooling level based on the heat it generates. This ensures optimal efficiency while conserving energy. However, the most advanced aspect of this laser lies in its advanced control systems. The Tactical Ultra-Short Pulse Laser, TUSPL, is equipped with sophisticated control systems that enable remote and automated operation. The TUSPL control system consists of several components working together to ensure the laser operates at its peak performance. These components include a laser energy control system, beam quality control system, and beam pointing control system. The laser energy control system regulates the transmitted energy, keeping it within the desired range. It also monitors the laser's temperature to prevent it from becoming too hot or too cold, which could affect its performance. On the other hand, the beam quality control system maintains the laser beam's focus and stability. It promptly detects any deviations in the beam and adjusts in real time to maintain its quality. Lastly, the beam pointing control system ensures the laser beam always points in the desired direction. It utilizes sensors and algorithms to continuously track the laser's position and orientation, making necessary adjustments to maintain accuracy. These advanced control systems work harmoniously, allowing the TUSPL to deliver a highly focused and stable beam of energy with exceptional accuracy. It comes as no surprise that this laser technology has rapidly become a pivotal component of the U.S. Air Force's arsenal. Not only is the Tactical Ultra-Short Pulse Laser a powerful weapon, but it is also highly efficient and cost-effective. It requires minimal maintenance and boasts a long lifespan. While the future of the Tactical Ultra-Short Pulse Laser is uncertain, it is undoubtedly a technology to watch closely. As it continues to evolve and improve, we can anticipate its integral role in the U.S. military's arsenal to expand even further.